This instructional video will explain the procedures for checking to make sure that measurements of grab samples of chlorine residual are performed accurately. This video can apply to both portable and benchtop instruments. Additional steps are required for calibration verification of continuous chlorine measurements, and these steps are not included in this video. Please refer to EPA Method 334 for continuous chlorine calibration verification. To ensure accurate measurements of field grab samples, we must check the performance of the instrument, the quality of the reagents, the cleanliness of the labware, and the skill and consistency of the sample collector. In this video, we will be showing the following: terms and equipment used, glassware and standard preparation, method blank and secondary standard, initial and routine instrument verification. This table summarizes the purpose, procedure frequency, and standards required for verifying your chlorine meter, and defines some of the terms that will be used in this video. Initial calibration. This is a procedure that uses diluted calibration standards to ensure the accuracy of the instrument. When obtaining a new instrument, or after a repair of an instrument, samplers must verify the internal factory-programmed calibration curve for grab sample instruments prior to placing the instrument into service. Initial demonstration of capability, or IDC, is a procedure to assess the ability of the analyst to generate acceptable precision and accuracy. The IDC must be successfully performed prior to analyzing any field samples. Quarterly check standard verification. Requires preparation and analysis of diluted primary standards once every 3 months. Secondary check standard verification is used to verify the accuracy of the instrument daily or each time a grab sample is collected. It can also be a surrogate to verify instrument performance between primary standard verifications. Secondary standards may be purchased for use with most DPD spectrophotometers or colorimeters. The accuracy of secondary standards must be verified on each recently calibrated spectrophotometer or colorimeter for which they will be used. Secondary standards may not be used to calibrate the instrument. Performance evaluation, or PE, is a test of unknown certified standards measured by an analyst to demonstrate the proficiency of the analyst. Method blank is an analyte-free matrix or deionized water to which all reagents are added in the same volumes or proportions as used in standard measurements. It is carried through the complete sample preparation and analytical procedure. The method blank is used to account for interferences or contamination resulting from the analytical process. Dilution standard. A chlorine dilution standard is a NIST concentrated primary chlorine standard diluted to an appropriate concentration. Next, let's discuss the equipment we will need to prepare our standards and perform the measurements. These pieces of equipment will enable us to prepare our standards and perform the measurements. Colorimeter or spectrophotometer. For this example, Hawk equipment and standards are being used, although equipment from other manufacturers is available. DPD reagent for free or total chlorine, colorimeter sample vials, Class A volumetric flasks, Class A pipette, concentrated standard ampule and ampule breaker, see Section 6.4 of EPA Method 334.0 for examples of products that can be used. Reagent-grade water, and secondary standards. We will also want to make sure we use equipment to ensure our safety and keep from contaminating our standards. These include glasses and gloves. We also need to make sure our reagents are prepared properly to prevent contamination of the standards. We want to make sure all the glassware we use does not have a chlorine demand that could alter our standard concentration. We also want to ensure that we do not use the same sample containers for free and total chlorine analysis. Chlorine demand-free glassware can be prepared by soaking the glassware at least 2 hours in a solution of 0.5 milliliters of commercial bleach, added to 1 liter of distilled or purified water, and then rinsing several times with purified water. Purified water, typically either deionized or distilled, is usually acceptable for this procedure. Chlorine demand-free water can be used if a chlorine demand is present. Chlorine demand-free water can be purchased from scientific supply companies or the colorimeter instrument manufacturer, or it can be prepared. If preparing chlorine demand-free water, add enough chlorine to distilled or deionized water to give a 5 milligrams per liter residual. Measure the chlorine residual after 2 days. If the residual is greater than 2 milligrams per liter, then dissipate the remaining residual by irradiating with ultraviolet light and use once all chlorine residual is dissipated. If the residual is less than 2 milligrams per liter, then discard and obtain different purified water. Before performing any measurements, we will perform a method blank. A method blank is a measurement using reagent-grade water, where you follow the same analytical steps as you would for the standard measurements. The purpose is to determine whether there is any interference from our sample vial or reagents, so that we can account for that interference when measuring our standard concentrations. We will fill a sample vial with purified water. First, ensure the vial is not scratched or stained, and rinse several times with reagent water. We wipe the vial with a lab wipe to remove any fingerprints. Place the vial in the instrument, align the vial according to manufacturer recommendations, place the cap over the sample vial, and then push the 0 button. The display should read 0.0. We then take our reagent and add it. We mix the reagent by placing the cap on the vial and slowly inverting to mix. Next, we place the vial back in the colorimeter and take another reading. The reading should be less than the minimum chlorine residual required by the state, or 1/3 the lowest standard used for the calibration curve provided by the manufacturer. In this example, we checked the manual, and the lowest calibration standard was 0.2 milligrams per liter. Therefore, this reading should be less than 0.07, which was calculated from 0.2 divided by 3. Now that we've looked over our equipment and prepared our glassware, let's prepare standards that will be used for equipment calibration verification. Chlorine dilution standards can be used for multiple quality assurance processes, including routine quarterly checks, initial demonstration of capability, and initial instrument verification. First, we will learn how to prepare a chlorine dilution standard, and then we will learn how to decide what concentration is needed for the test we are performing. Since primary standards don't come in the exact concentrations that we need, we will need to make dilutions for the concentrations that we need. In this example, we will be making a standard of 2.0 milligrams per liter, which is the concentration wanted, C want, in the equation. We check the label to find that our standard ampule contains a 68.2 milligrams per liter solution, which is C standard in the equation. In this example, we will be using a 100 milliliter flask, which is the volume of the flask, V flask, in the equation. We need to calculate the volume of the primary standard we will need to add to our 100 milliliter flask to get the desired concentration. This is called V add in our equation. Since chlorine only comes from our standard solution, we know the amount of chlorine is the concentration of our primary standard times the volume of standard we are adding. This must be equal to our diluted concentration of chlorine in the 100 milliliter flask times the concentration of the chlorine in the flask. We can express this with the equation concentration wanted times the volume of the flask equals concentration of the standard times the volume added. We know C want, V flask, and C standard, and we want to find V add, the volume of the primary standard we need to add. V add equals C want times V flask divided by C standard. So, for our example, 2.0 milligrams per liter times 100 milliliters divided by 68.2 milligrams per liter equals 2.9 milliliters. So now we will prepare our standard. First, we will fill the volumetric flask about 3/4 of the way with purified water. Now we open our ampule and pipette out 2.9 milliliters into our flask. This is the V-add we calculated from the example. Now we fill our flask the rest of the way with purified water. We want to have the bottom of the meniscus right at the fill line. Then cap the flask and invert several times to mix. The prepared diluted standard is now ready to use. It is important to note that the prepared standard should be analyzed as soon as possible after dilution, because the chlorine in solution can off-gas rapidly, which will change the concentration of the standard. Now we'll perform our measurement. First, we turn on the colorimeter. Now we zero the instrument. Be sure to rinse the vial with reagent water and a small amount of standard, then wipe clean. Ensure that the vial is aligned properly and according to manufacturer's recommendations. Now we remove the vial and add our DPD reagent. We can use DPD reagents for either free or total chlorine because both of these reagents can measure the free chlorine in our standard. You should select free or total based on the type of disinfectant residual that you have. If we were measuring in a water system using chloramine in the distribution system, we would need to measure for total chlorine. Now we mix our reagent. We do this by gently inverting the vial with the cap on. We don't want to shake it too vigorously, or we could cause air bubbles. If we are using total chlorine reagent, then we wait for 3 minutes for the color to develop. For free chlorine reagent, we take the reading right away. Now we take our reading and record the result. This result will be known as the concentration measured. It needs to be adjusted by the concentration of the method blank that was performed earlier. Now we rinse out our vial. If we need to repeat this procedure, rinse the vial with purified water and repeat the above steps, recording each of the other readings. Now that we've learned how to prepare and measure a chlorine dilution standard, we need to learn how to decide what concentration is needed for the quality assurance test we want to perform. Chlorine dilution standards can be used for multiple quality assurance processes, including routine quarterly checks, initial demonstration of capability, and initial instrument verification. This table shows the number of samples needed for each type of quality assurance test and what dilution concentration is used. Routine quarterly checks. Most of the time, we will be performing quarterly checks. Quarterly calibration verification checks are needed to make sure the instrument, glassware, and reagents are still providing accurate results. A quarterly check consists of 3 quality assurance procedures. First, a quarterly check begins with a method blank measurement. The procedure for performing a method blank can be viewed again, as this was discussed previously. Second, perform a calibration verification check using one chlorine dilution standard having a concentration near the mid-range or near the expected concentration in the field. Determine which concentration is appropriate for your water system and instrument, and review the video sections titled Chlorine Dilution Standard Preparation and Measurement, which were discussed previously. When performing your calculation, replace C-want with the real concentration that is appropriate for your water system and instrument. Perform a verification using secondary gel standards. Since we have not yet discussed this procedure, let's talk about that now. Secondary check standard verification. It is a good idea to perform regular calibration verification checks with the secondary gel standards to verify that the colorimeter or spectrophotometer is operating properly. Analysis of secondary standards does not replace the analysis of aqueous check standards. It is a good idea to perform these checks daily, or anytime the instrument has not been used for a significant period of time. For example, performing a check in the morning after the instrument has been off all night. Note that use of the secondary gel standards should not fully replace the use of primary dilution standards during a routine quarterly calibration verification. Secondary standards can be purchased from your instrument manufacturer and should span the entire range of concentrations that your instrument will be expected to measure. Note that secondary standards are not available for all colorimeter models. This equipment manufacturer provides secondary standards in 3 ranges: low range, from 0 to 2 milligrams per liter, mid-range, from 0 to 4 milligrams per liter, and high range, from 2 to 8 milligrams per liter. Note that some instruments only have low and high range settings and cannot be set to mid-range. The instrument that we are using can only be used with the low or high range standards. We will use high range standards for this example. The secondary standards come as 4 vials with a certificate of analysis. The certificate can be found in the box of standards and lists the allowable measurement ranges for the standards on different instruments. Generally, the secondary standards must be measured to be within 10% of their expected concentrations. Since we are using a pocket colorimeter too, the allowable readings for these standards are blank, 0.0, standard 1, 2.0 plus or minus 0.2, standard 2, 3.8 plus or minus 0.3, standard 3, 6.9 plus or minus 0.6. To perform a secondary verification, the meter should first be zeroed. Then we insert each standard vial into our instrument, wiping the vials before insertion, and write down the measurement. The measurement should be within the allowable range found on the certificate of analysis for your instrument. Wipe the standard vials before taking a reading to ensure that dirt and fingerprints do not affect the reading. For this instrument, the measurements are blank, 0.0, standard 1, 1.9, standard 2, 3.6, standard 3, 6.7. For this example, we have passed the secondary verification check because these measurements are in the allowable ranges. If the readings are not within the correct range, we will discuss how to troubleshoot your instrument at the end of this video. You will want to keep records of performing the secondary verification, which could include the date performed, measurements of the standards, instrument used, standard product number, and expiration date. If you have never performed an initial demonstration of capability for your instrument, you will need to perform this procedure once for each instrument that you use. If you have different people using chlorine instruments, each person should perform an IDC for each type of instrument that they use. The initial demonstration of capability consists of doing a method blank, 5 replicate dilution standards at the same concentration using either mid-range of the instrument or close to expected readings. We will use a concentration of 3 milligrams per liter since this is close to the dosage rate used by the local water system. To review the method to calculate and prepare the standard dilution, the video section titled Chlorine Dilution Standard Preparation can be viewed again for a better understanding of this procedure. After we prepare the primary standards that will be used for the 5 replicate samples, we will measure and record the result for each sample in order to determine how accurate our readings are. Using the example on the screen, we calculate adjusted chlorine by subtracting the method blank from the chlorine concentration. We calculate the average of the 5 replicate values of adjusted chlorine. We calculate the percent difference between the adjusted chlorine and the wanted chlorine concentration. If the result of the percent difference is less than or equal to 15%, then the accuracy of the 5 replicate standards passes the IDC. Next, we need to determine the precision of the 5 replicate samples. Using the example on the screen, we calculate the difference for each sample from the average of adjusted chlorine replicates. This difference is calculated by subtracting the adjusted concentration for a sample from the average of all 5 samples. Next, we take calculated difference and multiply it by itself. This value is known as the difference squared. We can then sum the 5 results for the difference squared. Then the standard deviation is calculated. It is equal to the square root of the term that is the difference squared divided by the number of samples minus 1, which for our example is 4. The square root can be calculated by using the square root function on your calculator or spreadsheet, or by raising the value of the term to the exponent power of 0.5. Next, we calculate the relative standard deviation. The relative standard deviation is calculated by dividing the standard deviation by the average of the 5 replicate values of adjusted chlorine and multiplying by 100. If the result of the relative standard deviation is less than or equal to 15%, then the precision of the 5 replicate standards passes the IDC. If either the accuracy or precision value is greater than 15%, please try again. Here are some possible reasons that may cause the results to be outside the acceptable range. If, after multiple attempts, the issue is not found, it may be necessary to have the instrument checked or recalibrated by the manufacturer. If you have purchased a new instrument, you are required to perform an initial instrument verification. The initial instrument verification consists of the following steps: a method blank, at least 3 calibration standard dilutions that match the instrument factory calibration dilutions, low, at or below 0.2 milligrams per liter, or minimum residual required by the state, and at least 2 other concentrations that span the expected range of chlorine residuals. For our instrument, when we were to perform this procedure, we would make 3 chlorine dilution standards using the 3 concentrations of C-want, having 0.20, 1.60, and 3.50 milligrams per liter, because they match the concentrations of the factory calibration as performed by the manufacturer. Using the chlorine dilution standard procedure discussed previously, the concentrations to be added to the flask would be 0.30 milliliters for a concentration of 0.2 milligrams per liter, 2.35 milliliters for a concentration of 1.6 milligrams per liter, 5.1 milliliters for a concentration of 3.5 milligrams per liter. The video sections titled Method Blank and Chlorine Dilution Standard Preparation and Measurement can be viewed again for a better understanding of these procedures. If your primacy agency requests or your water system decides to perform a performance evaluation, a certified standard solution of chlorine having an unknown concentration would be purchased. The performance evaluation procedure describes the amount of the certified standard to be added to a known volume of purified water. Then, the measurement of the unknown concentration can be checked for individual analysts by reporting the results to the certified solution provider for comparison to the allowable range. This video demonstrated the procedures for performing calibration verification checks for a chlorine meter using primary and secondary standards for chlorine grab samples. This table summarizes the procedures and standards required for performing calibration verification checks for a chlorine meter. Remember, validating the factory calibration curve and performing the initial demonstration of capability, or IDC, are one-time startup procedures. The routine calibration check must be completed at least quarterly. Every sampler or analyst needs to demonstrate their ability to perform the analysis consistently, to ensure instruments are operating properly and to ensure that reagents used are effective. Be sure to properly document Method 334 steps, consistent with your state or local regulations. For additional information, or for the method of performing a calibration verification check for an online continuous chlorine analyzer, refer to EPA Method 334 or the equipment manufacturer's procedure, such as HAWC Document DOC 0.53.01302.